Hello, hi out there. Today we'll be discussing the speed control of DC shunt motor. DC shunt motor with by armature side. Okay. So we will be having different circuit diagrams for this. So overall, what we require for this is first one DC shunt motor. DC shunt motor, then field rheostat, the next armature rheostat, and starter, that is 3-point starter. In 3-point starter, what we'll be having, first one will be line, then followed by field, then followed by armature. This is called line. This is the field terminal. This is the armature terminal. Next we will be having MCB or DPST, double pole single through switch. Okay, so these are the equipments needed, and also we require some measuring instruments. So we require one more equipment called DC voltmeter and DC ammeter. Okay, so these are the equipments required for the for conducting the experiment of DC shunt motor, speed control of DC shunt motor. Okay, so we will be seeing the simulation now. So we will now see the simulation outputs by doing this. We will be conducting the lab simulations, that is DC shunt motor speed control by armature resistance. Okay, so before going to the simulations, you need to understand the instructions carefully. Okay, after reading the instructions carefully, you need to have the theory part. So while you are writing the experiment, you require to have aim, apparatus, theory, procedure, precautions, calculations, and then if there are some graphs, plot the graphs, then after the conclusion or result. So these are the points to be kept in your mind every time. Okay, okay. Okay. Now we will see the main circuit diagram. Okay, let me rotate my screen here. So here are the instructions. Here are the instructions you have to follow. First of all, the MCB positive. The positive MCB should be connected to the negative terminal of the voltmeter. So MCB is connected to what? Negative terminal of the voltmeter, and as well as this positive is connected to motor armature negative. A2 means negative, as well as positive is again connected to motor field. Okay, motor field. Then next what we have, then connect to the negative terminal of MCB, negative terminal of the MCB to line of the starter. Okay. Next, the F port, that is the field winding, the field terminal in the starter should be connected to positive terminal of the ammeter. You can see this, yes, blue color line. Field winding is connected to the field point, the field terminal in the MCB or field port in the starter is connected to ammeter positive terminal. Okay, then after that, armature port in the starter is connected to positive terminal of the ammeter. Okay, the field winding port of the starter is connected to positive terminal of the ammeter. Okay, then next, the armature terminal in the starter is connected to positive terminal of the armature resistance. Positive terminal of the armature resistance, you can see here, green line. Okay, so armature port in the starter is connected to field armature resistance positive terminal. Okay, next, positive terminal of the voltmeter is connected to negative terminal of the armature resistance. Positive terminal of the voltmeter is connected to negative terminal of the armature resistance. You can see blue line. Positive terminal of the voltmeter is connected to negative terminal of the armature resistance, and the same positive terminal is connected to again armature positive of the motor. So same, you can see here, I am dragging this blue color line. This should be connected to motor armature positive terminal. Okay, the next connect to the ammeter negative. You can see here, ammeter negative is connected to the field winding positive terminal, field resistance positive. Ammeter negative is connected to field resistance positive. You can see the green line. Okay, the green line. Then next, negative terminal of the field resistance. Negative terminal of the field resistance is connected to F1, field winding positive of the motor. And next, this armature positive of the motor is connected to negative terminal of the armature resistance. So negative terminal of the armature resistance is connected to armature positive. Okay, so these are the connections. Okay, we'll check here, all connections are correct. Okay, so we will do, now we will run the motor just by varying what type of control it is. Speed control is based on armature resistance, so we have to vary the armature resistance by keeping the field resistance constant. So we won't vary the field rheostat, we will be varying the armature resistance. you can see the secondary rheostat, that is what the armature resistance. So we have to vary that. So if initially the speed is what 0, you can see in the speedometer. Okay, you can see it in the speed meter. You can see here I am changing the armature. So first of all you have to switch on the MCB. Okay, once you switch on the MCB, everything will be on. So what is the rated voltage we have kept here? 220 volts. What is the rated voltage? 220 volts. You can see in the voltmeter. And what is the rated current we have maintained here? 0.8. So that is what when the armature resistance is at 0. We have what is the speed we have here? 1360 RPM. So at 220 volts, what is the speed we have? 1360. Now, as you can see, so we have to maintain the field resistance constant and we have to vary the armature resistance. So that thereby speed control of DC shunt motor by armature resistance. Now you can see speed will change here. The moment I increase the armature resistance, so voltage will be what? 180 volts. What is the speed we have here? 1080. So let us add this point. Okay, let us increase in number of 20. So (160). What is it? 160 volts. What is the speed we have? 950. So we will be adding all these parameters for the table. You can see here. Serial number 1 at 180 volts, what was the speed? 1080. At 160 volts, what was the speed? 950. Okay? Friends, I hope you understood. Now, the moment I increase a resistance here, the voltage was up to at 140 volts. What was the speed now? 825. So we'll add this to the table. Now we will increase furthermore 120. At 120, what was the speed? 690. Next, a furthermore increase in the furthermore decrease. Let us measure the speed at 100 volts. At 100 volts, what was the speed now? 580 RPM. We will add that to table. At 80 volts, what was the speed now? 450 RPM, revolutions per minute. Okay, now the rheostat is at its own position. Okay, at its extreme position. So at 80 volts, we have 450 RPM. You can see the motor is at slow rotation. Now you understood, right? So these are the different parameters, so that we have varied the voltages by varying the armature resistance by keeping the field rheostat as a constant position. I hope you understood. Now we can even create a graph for this. So what will be the graph? The graph will be plotted between the voltage and speed. You can see the two columns in the table, voltage and speed. Okay. At 180 volts, what was the speed? 1080. So as the voltage is decreasing, constantly the speed is also decreasing simultaneously. You can see the graph, it forms a linear straight line. Okay. I hope students you understood. If you have any doubts, please comment below. And this is what the speed control of DC shunt motor with armature resistance. Okay. Thank you.